In this video, let's take a look at the Spectral Repair module. Now, this module, in its most basic form, allows you to paint away undesired sounds and frequencies. You do have different modes. Going through these tabs here, you can either attenuate, replace, use a pattern, or use partials and noise to get rid of those noises that you want to sort of paint out in your sound. Let's go through each of these different tabs and how they work with your sound. First, I want to play back the audio sample that I'm going to be using. This is me talking, and then there's a slight bird chirp sound over here, and then there's a click sound over here. Take a listen. This is testing out the Spectral Repair module, where there's other sounds that we want to remove in the frequency domain. So that bird chirp over here sounds, and in this click here domain. So these sounds sit in different frequencies. If I just had to go and delete it, obviously it would cause problems. So that's where we use a thing like Spectral Repair to replace, attenuate, or change the pattern of the sound so that you can minimize the sound of that noise in your audio. First, you need to sort of isolate and select that noise that you want to remove. I'm going to move over more to the spectrogram view, and I want to change the frequency scale to extended log. And I think the bird sound or bird chirp is somewhere over here, the sounds. So if I use my lasso tool and I lasso around here and I use play selection, that sounds like the bird chirp. I just want to draw around slightly higher. That sounds like the chirp. Now, if I go and delete that, so if I go to edit and delete, it's going to leave a bit of a hole in the sound module where there's other sounds that we want. So it leaves a bit too much of a gap. The other thing I could possibly do is I could make a selection of a different noise floor area. So I'm going to copy that, so that area there, and paste over there. Where there's other sounds that we want to remove, it's slightly better, but it's still not quite right. So that's where the Spectral Repair and attenuation comes in handy. How this works is it reduces the noise by looking at the surrounding areas and using the surrounding areas to paint over that area that we have selected so that it sounds like that noise floor is the same, but it removes that noise. So I've made the selection, and as you can see, there's this little square block around it. If I go down to surrounding region length, I can increase that size. So it's trying to grab more of the noise floor or ambient sound around it. Then I've got before and after weighting. So I can change the weighting. This is moving it up or down because it's using the vertical interpolation. I could switch to horizontal and change the weighting. And obviously there's some things that you don't want to grab. So here is maybe more of another sound that I maybe don't want. So I can weight it more to the other side. I'm going to stick with horizontal, but I could also go for a 2D shape. And then the strength is the amount that I want to reduce or attenuate. I can increase the bands. This will give me a better resolution because it's going to look at a bigger surrounding area. But if you've got a smaller sound, it's better rather to use less bands. So I'm going to stick with less bands. Multi-resolution will generally just make it sound better, so I'm going to tick that as well. Now let's compare this. I'll click compare. And now I can preview. So here is the original sound. Going from here, where there's other sounds that we want to remove. And then here is with the spectral settings, where there's other sounds that we want to remove. So that worked pretty well. Let's go back to here, push up the strength, increase that surrounding region, maybe weight it to the center and make it 2D. So it's grabbing more of everything, and then compare that. So the original, where there's other sounds that, and then Spectral Repair settings too, where there's other sounds that we want to remove. So as you can see, it hasn't removed it as well. I preferred settings 1, where I had a smaller area using the horizontal, where there's other sounds that we want to remove. That works quite nice. Another thing I can do is run multiple passes or multiple renders of that. So going to that, I'm going to render it out, render it again, and for a third time. And now we've got this. Where there's other sounds that we want to remove, maybe making the selection slightly bigger for one more pass. So I'm just going to grab this area there, render it out, and let's hear that. Where there's other sounds that we want to remove, that got too much into the voice. So I'm going to remove that and maybe just make one more selection a bit higher. Check the play selection. Maybe a bit higher. Where there's other sounds that we want to remove in the frequency. That's come quite far. If you go right back to the beginning state, you've got this, where there's other sounds that, and now going where we've done a whole bunch of attenuations, and we left with this, where there's other sounds that we want to remove. So you're not trying to remove it completely. You're just trying to minimize it to quite an extent so that it's not distracting you when you're listening. And I think that's done the result quite well. Now let's check out some of these other options. I'm going to go back to the initial state where I've got my selection, and let's jump over to replace. So with replace, you also got your band selection. You've got your surrounding areas. But what it's going to do is it's going to replace that selection with noise that is picked up in the surrounding areas. So this will sort of fill the gaps instead of creating a gap, where attenuating is just taking the selection and reducing it, but still looking at the surrounding areas, where replacing is replacing it with the surrounding area to sort of minimize that gap sound. So let's render this out and take a listen. Where there's other sounds that we want to remove in the works okay. For this particular sound, it sounds like it's smearing it a bit where it's going across. So let's undo that and let's use less bands, increase that surrounding area, and maybe weight it a bit more to the side. Where there's other sounds that we want to remove, yeah, it's not too bad. So with the initial state, where there's other sounds, and then after the replace, where there's other sounds that we want to remove, working quite well. Now let's move over to pattern. Also jump back to the initial state. With this, you've got the same things. You've got the amount of bands you can use. I'll reduce that. You've got your surrounding areas. Now with pattern search range, it uses this to search for audio which matches the surrounding interval. So it's looking for surrounding patterns to replace that selection with. This works really well if you increase that surrounding area like we've done. So let's render this out and see what happens. So as you can see, the pattern has changed. It's created a match of some patterns and moved them across. Where there's other sounds that we want to remove in the, but it doesn't always work quite well for all audio sources. For this, it's not working well because it's copying across from another pattern here and you're getting different sounds. Where there's other sounds that I'm going to move over to another sound now and show you how this can work better. Okay, so here is another sound. This is a sort of city ambience-scape, and it's got a bit of a car hoot sound in here. So if you take a listen, you've got that hoot there. I'm going to move this across to more of the spectrogram so we can see it more clearly. Maybe we can change over to log, and you can see all the harmonics there. So I can make a selection. I'm using the square selection tool, and there we've got that. I'm choosing the surrounding areas. I'm going to increase that and looking for similar patterns. Let's actually use a wider band. And now we're going to render that out. Now we've got this. And you can actually barely hear it there. Looks like there's slightly bit down here, so I'm going to make a selection here as well and run that again. And that really has worked great. So it's taken patterns from this spectrogram meter and copied it across, making it a smooth transition when that sound has been removed. And then here, after 2 renders of the spectral repair pattern mode, I can barely even hear it anymore, so it really has worked well. Now let's take a look at the last module, which is partials and noise. Now this is an advanced replace section where it enhances the harmonics or partials of a sound. So you've got this extra dial over here, harmonic sensitivity. So you can use this if you want to detect more harmonics in the selection. So let's go back to the initial state. Let's use this. I'm going to make the same selection. I want to increase the harmonic sensitivity, maybe reduce that surrounding areas, and I'll leave the weighting at the center and maybe jump this down to a lower band and render this out. This does take a bit longer to render out because it's looking through all the partials and the noise. Maybe do one more render using a bigger surrounding areas and weighted a bit more to the left. That reduces it, but there's still harmonics in there, and I actually preferred the pattern mode for this sound. But you get an idea of how you can use the different tabs here and their different properties to reduce noises within the spectrogram meter of your audio. Now let me jump back to that other sound and just quickly show you all of them again. I've got that click sound that I want to remove in that first audio that we used. Okay, so jumping back now to this original audio file that I showed you in the video, there's also this click sound over here. I want to remove in the frequency domain. Now let's see how we can remove this click by going through the different tabs and seeing which one works the best. So I'm going to zoom in. I'm going to make a selection. It's going to be a vertical selection, and I'm going to use the horizontal direction of interpolation. For attenuate, we're going to maybe just set the surrounding bands over here and change the strength. And I'm going to compare that. So that's attenuate. Then replace, we'll do the same thing. And then go to pattern, use a smaller band, and then partials and noise. It doesn't need to be so weighted, and smaller bands, and compare. Another thing you can do is you can actually rename these previews. So this will be attenuate, this will be replace, this will be pattern, and then this will be partials and noise. So I'm just going to zoom out, and we're just going to take a listen here. So this is the original that we want to remove in the frequency domain. This is attenuate, remove in the frequency domain. This is replace, we want to remove in the frequency domain. That smears it a bit, pattern, that we want to remove in the frequency domain. That's copying across the pattern. It doesn't work very well with this click sound, and then partials and noise that we want to remove in the frequency domain. Also smearing it a bit. I could have probably gone with smaller bands and used a smaller surrounding area, but that was just a quick test just to show you the differences between the different functions that you can use to replace the spectral noise. After looking through all those, I think attenuate works the best with this click. Remove in the frequency domain. So that covers the spectral repair for you and how you can use these different tabs to replace sections of noise that you've selected, and then how you can use the surrounding areas to make the noise floor match so it doesn't feel like a gap in your audio. Catch you in the next video.